Let's take a look at integrating problematic functions, or integrating functions that technically, as written, can't be integrated. So there are two problem spots that we need to avoid. One or both of the bounds of integration are at plus or minus infinity. So if we're integrating to infinity or we're integrating to from negative infinity, we can't do that because the bounds have to be real values. And then any point where the function is undefined, we can't integrate there either because we need to have defined values. So basically all of our integrals need to have defined values at every point. So what we end up doing though to deal with this is to be clever. So we replace the problem with a variable. Most common we'll see the lowercase b, but doesn't always have to be. And then use limits to evaluate. So let's look at a couple examples of this. With infinite bounds, the integral from negative infinity to 0 of e to the x dx. So we can't deal with negative infinity. It's not allowed because it's not a defined value. But what is allowed is to say limit as b approaches negative infinity of the integral of b to 0 e to the x dx. So now we're integrating from b to 0, and b is a defined value. And then when we finish the whole problem, then we'll take the limit as b approaches negative infinity to figure out what actually happens as this function approaches negative infinity. So the integral of e to the x, limit b approaches negative infinity. Integral of e to the x is e to the x, and then we put in our bounds, so from b to 0. So then we have the limit as b approaches negative infinity of e to the upper bound of 0 minus e to the b. E to the 0 is 1, and e to the negative infinity is going to be 0. So this is equal to 1. 1 minus 0, which is 1. So you'll see what we did there is we replaced the problem, the negative infinity, with a b. We evaluated, then we took the limit as b approached negative infinity. So this is the true answer to it. It's just we need to kind of do things that are legally allowed in math. So be careful with this. If there's a free response question on the AP test and you just put in the negative infinity and you don't have this limit expression, that is wrong because technically this is not allowed in mathematics in the integral. I know it feels like we're just doing a technical jog or skip around, but there is a reason that this is allowed, that the reasons why it's what we're doing here is allowed gets more complicated than is worth getting into at the moment. Let's look at a second example of an undefined point. So in this case, and I'm actually going to change this real quick to make it a little more interesting. So if you want to swap this in your notes, you can. So this expression, that should be an x, not a 2, is undefined when x equals 0. So what we're going to rewrite this as is we're going to swap out that 0, that problematic point, with a b. So I'm going to integrate from 2 to 0. First I've got to kind of separate out my problem spot of 1 over square root of x dx plus the integral from 0 to 1 of 1 over square root of x dx. So we've made it so our problem spot is kind of separated. If you had just 0 to 1, it'd look exactly like the previous problem that we did. But I'm doing this so we see a little more interesting behavior. So now we're going to take the limit as b approaches 0 of the integral from negative 2 to b, and this is going to be from the left-hand side, because we can see we're coming from the left-hand side of 0. 1 over square root of x dx plus the limit as b approaches 0 from the right-hand side. And I don't know if this will end up being important because I just changed on the fly here, but I am putting them in because they might end up being important whether it's left or right-hand side. 1 over square root of x dx. So now we can evaluate both of these, limit as b approaches 0 from the negative side. X to the negative 1/2, if I add 1 I get x to the 1/2, so this should be 2 x to the 1/2 from -2 to b plus limit as b approaches 0, positive side of 2x to the 1/2 from b to 1. So that's going to be the limit as b approaches 0 from the negative side of 2b to the 1/2 minus 2 times -2 to the 1/2. And that's why I couldn't have the negative in here. Okay, so my swap, if you had seen this earlier, great. But my swap doesn't work here, so this whole bit we're just going to ignore, pretend like that didn't happen. We can still do the right-hand side. I knew I'd put that in there for a reason, but I was trying to get clever here. So again, we're just going to go back to the original and say 0. The limit as b approaches 0 from the positive side, and then we have 2 times 1 to the 1/2 minus 2 times b to the 1/2. And then as b approaches 0, that's going to be just 0. So we end up with a final solution of 2 here. If you have any questions, let me know. But otherwise, that's kind of wrapping up what we're looking at with integrals here.